There's two approaches that make sense for doing 2's complement subtraction. The first is to just do it straightforward as we would do with decimal subtraction. So in this case, I'm trying to take away a 1 from a 0 and I can't, so I want to borrow from the previous place. But that doesn't have a value either. It's a 0, so I need to borrow from the previous place. And so I'll take this 1 in the third column, and it becomes a 2 in the second column. But since I'm trying to work in the first column, I again need to borrow from that column, so I'll take one of those and make 2 in the first column. Now I can take 1 away from 2, that yields 1. In the next column I can take 1 away from 1, that yields 0. And I have a 0 in the top of the third column, and I can take 0 away from 0. So the result of this 3-bit 2's complement subtraction would be 0, 0, 1. So that's one way. The second thing I could do is take the bottom number and negate it and add it to the top number. So I could do our 2's complement negation operation, which is to flip all of the bits and add 1. And then I could add that to the top number. So 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 1, I'd have a carry out and write down a 0. So you can see that also gets us the 0, 0, 1 that our previous technique did. Now we need to determine whether overflow occurred. And there's two ways we could do this. One is to look at and say, we have a negative number and we're subtracting a positive number from that negative number. So we'd expect the result to be negative. But in fact it was positive, that 0, 0, 1 is a positive number. So from that we could determine that overflow occurred. The other way that we could determine that overflow occurred is to look at this addition and notice that there was no carry into the most significant bit position, but there was a carry out. And so if we know that the number of carry ins and carry outs out of this bit position is odd, we know that also indicates overflow.